Okay, this video is going to be over similar triangles and how to solve for similar triangles. Also, how to prove that they are similar. So we're going to learn the three different similarity theorems. So first, let's talk about the definition of similar triangles. A similar triangle, they have the same shape but not necessarily the same size. But all angles are going to be congruent and all their sides, all their corresponding sides are going to be proportional. So what is corresponding angles and what is corresponding sides? If I have a triangle, BC, and then I have another one, and I say that these are similar, then, okay, and I say that these are similar, okay? So what corresponding sides means that they're in the same position on the other triangle. So AB corresponds to ED. So we know these are right triangles, so we know that these triangles are turned the same way. So AB corresponds to ED, AC will correspond to DF, and BC corresponds to EF, okay? So it's corresponding sides means they're in the same position on the other triangle. And to be similar, their sides have to be proportional. So if this is 10 and this was 5, and I said this was 8, this would need to be 4. The reason why is because the relationship between 10 and 5, 10 divided by 2 is 5. And those are corresponding sides. So these two have to have the same relationship too, since they are the corresponding sides. So 8 and 4. And then if I said this one was 15, this one would have to be 7.5, okay, 7.5. So they all have the same relationship, meaning that they are similar triangles because all the sides are proportional. We're all dividing by 2. All the corresponding sides have the same relationship of dividing by 2. So that's what corresponding sides means. Now corresponding angles, so corresponding angles, I'm going to erase these sides. It's the exact same as corresponding sides where they're in the same position. So A corresponds to angle D, B corresponds to angle E, and angle C corresponds to angle F. And all corresponding angles in a similar triangle are congruent. So those are the two things that have to happen. All angles are congruent, and all corresponding angles are congruent, and all corresponding sides are proportional. Now let's talk about the three similarity theorems. So the first similarity theorem is called Sidesideside, or SSS for Sidesideside, Sidesideside, which means that we can prove that all the triangles are similar if given all three sides and all three sides are in proportion. So for example, if I have a triangle and 12, 5, 13, and then I have another triangle. And so these are my two triangles. And if I can prove that each ratio to their corresponding sides are equal, then I can prove that this is similar by side, side, side. So basically 5 corresponds to 4, so 5 over 4 is equal to 13 corresponds to 10.4 is equal to that, and then 12 corresponds to 9.6. So if this is true, if all of these are equal, because 5 corresponds to 4, those are its corresponding sides. If all of these ratios are equal, then these are similar triangles by side, side, side. And in this case, this is true because these will all go down to 1.25. 1.25. So these triangles are similar by side, side, side. The next triangular similarity theorem is Sideangleside. So SAS, Sideangleside. So if we have two triangles, nope, I'm gonna make this one bigger. Okay. So here, if I have two triangles and it has two sides that are in proportion and then one angle in between those two proportional sides, then I can prove that it's similar by side angle side. The angle does have to be in between the two sides that you're proving to be proportional. It couldn't be this angle over here because it has to be side angle side. So it has to be between the two sides that you're proving to be proportional. So in this case, if I put 5 over 7.5, it should equal 7 over 10.5 because those sides have to be in proportion for it to be similar. So 5 over 7.5, because those are corresponding sides, is equal to 7 over 10.5 since those are corresponding sides. And in this case, they both equal 0.6 repeating. So we know that the sides are proportional, and then the angle in between is congruent. So we can say that they are similar by side angle side. So that's the second theorem. The third theorem is what we call angle-angle similarity theorem. Just angle-angle. If we can prove that two angles of a triangle are congruent, then we can prove that they are similar because that third angle is going to automatically be congruent since all triangles add up to 180. So we have a triangle here, and it's 70 and 50 are the angles, and then we have a littler one, but we still say 70 and 50 are the angles. So we're given that two angles are congruent, and this angle corresponds to that angle, this angle corresponds to that angle, so both the corresponding angles are congruent. We can state that this is similar triangles by angle-angle. We don't even have to need any of the sides because if all angles are congruent, then those triangles are similar no matter what. And if we can prove that two angles are congruent, then we know that third one's congruent since they all, again, add up to be 180. So those are the similarity theorems. Now we're going to talk about finding a missing side of a similar triangle by using a proportion. So you can go and watch the proportions video if you don't understand proportions. I have made a video over that. So let's just see this. So 28x, we know that that's 35. And then we have another triangle, 42, 33, and 35. So in this case, you see that we have an angle 35 in each of these. So we know that 28 corresponds to 42 and x corresponds to 33. So we can write our proportion that way. 28 corresponds to 42 and then x corresponds to 33. Notice that 28 and x are on top and they're from the same triangle. So if you pull from this triangle first, then you need to pull from that triangle first here too to write your other proportion, your ratio. So 28, I always do corresponding side over corresponding side is equal to corresponding side over corresponding side. Then we have a proportion and we can solve it. Again, if you need to know how to solve proportions, go and watch that video. I'm going to do the Okay, so we're going to use the butterfly method. 28 times 33 is 924 is equal to 42x. Then we divide both sides by 42 and we get x is equal to 22. So that is how you find a missing side of a similar triangle. So let's do a few more. Let's do one more. Let's see if I can draw this. Okay, so I'm drawing this. So in this case, if you notice, you can see a smaller triangle and then compared to that bigger triangle. I like to redraw the triangles in separate pictures. So that's what I'm going to do. I'm going to draw that small triangle, 9, 6, and then we don't know that side. And then the bigger triangle, that'd be 18. Oh, 12, and then 22. Sorry, in that first picture, I forgot to write the 12 there. It's a 12. So the smaller one, if you notice, it's 9, 6, and then X. We don't know that side. And then in the bigger one, you can see that it's 18 because 9 plus 9 is 18. And then 12, and then that whole side was 22. So now I have my two similar triangles. I have several options here. I can do 6 over 12 or 9 over 18. I can use either of that ratio, but obviously I have to use the ratio of x over 22 to solve for x. I'm going to choose to use the 9/18 ratio. So 9 to 18 is equal to x over 22 because 9 corresponds to 18 and x corresponds to 22. And then I do my butterfly method. 22 times 9 is 198. So 198 equals 18x. I'm going to divide both sides by 18. And x is going to equal 11. So x is going to equal 11. And that is how you solve similar triangles. Thank you for joining. Thank you for watching Jesseline Live. Bye.